Hey guys, tonight I'm going to work through some example problems for topic 3 of Unit 2, which is writing electron configurations and the shortcut, which we call the noble gas configuration. Two things that you should have out anytime you do any of these electron configurations are a regular periodic table and a copy of the blank one that we filled out in class. If you've got really sharp eyes, you may notice that this one that I copied off the internet has a few differences than the one that we filled out in class, and that's just because in the real world there are a few exceptions scattered throughout the periodic table, especially in the D's and the F's, that sort of break the pattern that we followed in class. But that's beyond the scope of our class, and we'll stick to just following the pattern that you wrote down. So follow yours exactly and ignore maybe any of the exceptions that you might notice on this one. If you remember how this got started, was Bohr was the first person to notice that electrons occupy specific points in the electron cloud. Later work then discovered that these different places that they could occupy, known as orbitals or sublevels, had different shapes, and there were four varieties of them: S, P, D, and F. And each of these sublevels had different capacities to hold electrons: 2 for S, 6 for P, 10 for D, and 14 for F. And that gave rise to sort of the boxy shape of the periodic table, where this part right here, if you were here, it's too wide, you're in an S. If you're on this part of the periodic table that is 6 wide, you are in a P. If you're in this skinny part in the middle, that is 10 wide, you are in a D. Or if you're on this part down here on the bottom, that's 14, you're in an F. We also noted that there are a few breaks in the way that these orbitals fill. For instance, this first row of D's, even though it is in the fourth row on the periodic table, actually belong to the third shell. So we wrote ourselves a reminder that the D's are always one back. And similarly, the F's, the first place that you encounter them, are in the sixth row, but these F's actually belong to the fourth shell. So we wrote ourselves another reminder that F drops 2. So just keep that in mind as we work out these examples. One of the primary goals for writing these electron configurations is to find the number of valence electrons, which are the electrons in the highest outermost shell. We care about them especially because anytime bonding goes on, it's the electrons on the outermost shell that are going to be bonding first. And if we know how many valence electrons we have, we can predict a lot of the bonding behavior an atom would like to do. So let's get started with this example here. Do nitrogen. I find nitrogen here on the periodic table. It's atomic number 7. And I find the corresponding square on my blank periodic table, which is 2p3. What that tells me is that the last 3 electrons go into the second shell in a P-shaped sublevel. But I also need to account for the fact that nitrogen has other electrons besides just these 2p3. And so the pattern is to write the last part every time you change letters until you get to the place that you stop. And I notice on this, to get to 2p3, I have to go through the 1s's, the 2s's, and then arrive at the 2p's. So I'm going to write the last part of 1s, the last part of 2s, and then I'm partway through 2p, so it's the third one there. You can check your work. Nitrogen is atomic number 7, so it should have 7 protons and 7 electrons. I've assigned 2 electrons here, 2 electrons here, 3 electrons here. 2 plus 2 plus 3 is 7, so I've assigned the right number of electrons in the right order. Now let's look at the valence electrons. Nitrogen has 2 shells, the first shell and the second shell, but be careful that the second shell does have 2 parts, an S part and a P part. So it's the electrons in both of these parts of the second shell that are going to be my valence electrons. So the valence electrons are the 2s2 and the 2p3. So these guys comprise my valence electrons. So it has 5. Okay, for my next example, I want to do an element a little further down the table. It's vanadium, atomic number 23, which corresponds to 3d3 on this periodic table. So again, I'm going to follow the pattern of going through all the different letters that it takes to get to 3d3. So that's the 1s, 2s, 2p, 3s, 3p, 4s, and 3d. So last part of the 1s, last part of the 2s, of the 2p, of the 3s, of the 3p, of the 4s, and then I am 3 into the 3d. If I want to check my work, it's atomic number 23. 2 plus 2 is 10. Sorry, 2 plus 2 is 4, plus 6 is 10, getting ahead of myself. Plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 3 is 23. So, right number of electrons. My valence electrons, I check all my first numbers for my shells. The fourth shell is the highest shell. There's only one part to it. So the 4s2 contains 2, and I have 2 valence electrons. Now I'm going to pick an element way down here on the periodic table to make sure that we can practice using our F's. So I picked atomic number 82, and that's lead. And so I have a lot of parts to get through to get down to lead. The 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s. Don't forget your 4f's. Then you can come back up, pick up your 5Ds, and finish off at 6P2. So let's write all of that out. 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2. Don't forget to go down and pick up your 4F's, then come back and get your 5Ds, and then finish off at 6P2. That was a long one. Pick this long one so on the next slide you really appreciate how much the shortcut saves us. I want to check this if we wanted to. 2 plus 2 is 4, 10, 12, 18, 20, 30, 36, 38, 48, 54, 56, 70, 80, 82. So I've assigned the right number of electrons. My valence electrons, I want to go through all of these first numbers looking for the highest ones. The highest one is the 6, and I do have it in 2 parts on this one, a 6s and a 6p. So my valence electrons are all the electrons in the 6th shell. So I have 4 valence electrons in this one. Now let's look at this shortcut, which is known as the noble gas shortcut. Although for these short elements, I'm going to do N, the first example that we did. It's not going to save us a whole lot, but when we get down to practicing the ones down here, I think you'll agree that it saves us a whole lot. Remember that the noble gases are this last column here, and we use that as a convenient starting point for the shortcut because they are at the end of a row. So what we will do is we will find the element in question and then go to the noble gas that comes before it. In this case, the noble gas that comes before N is at the end of the previous row. It's He. So I put He. And then I only write the configurations that come after He, which is 1s2, until I get to the element I'm being asked about. So to go from here to where nitrogen is at 2p3, I have to go through the two S's and then to the two P's. So I'm just going to write those, 2s2, 2p3. And this is the shortest way that we can write the configuration to guarantee that we pick up all of the valence electrons, which in the case of nitrogen, as we mentioned before, is the 2s and the 2p. So I can still see that I have 5 valence electrons because of the 2 here and the 3 here. The noble gas shortcut is going to save us a little more on this one, because now I find vanadium, and the noble gas that comes before it is Ar, so I put that in brackets. And this is going to save us more because now Ar takes care of the 1s2, 2s2, 2p6, 3s2, and 3p6. So instead of having to write all of that, Ar stands in place for it. And I only have to write the configurations that come after Ar till I get to vanadium. And so that is my 4s and then my 3d. And that's it. So that saved us quite a bit of work. We can check our valence electrons. Fourth shell is the highest one that I see. Force 2 contains 2 electrons, so I have 2 valence electrons. My last example here, the noble gas shortcut, will be for lead that we did earlier. So I find the noble gas for lead, and that is xenon. So put xenon in there. And that stands in for a whole lot of stuff, all the way through 5p6. So writing that stands in for the 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, and 5p. So that saved me a whole lot of writing. And now just have to write the 6s, still have to write the 4f's even in the shortcut, the 5d's, and the 6p's. And we can look through this list and see that my valence shell is the 6th shell. So 6s2, 6p2, so 4 valence electrons. My last 3 examples are going to be writing the noble gas configuration, not just for neutral elements, but for ions. And it's really just one step at the beginning to take care of whatever this charge is, and then you'll be in good shape. So if I find nickel, it's here, and that is 3d8 on the periodic table, but that would be for neutral nickel. This is nickel 2+, so it's lost 2 electrons. So I go back 2 squares on the periodic table, and what I'm really asking you to write the electron configuration for is something with 26 electrons, and so that would be Fe. So just remember that when you're doing these questions that have charges, find the different square that it will be on the periodic table after it has either gained or lost those electrons. So I'm going to write my answer as if I had been asked to write the electron configuration for Fe. So my noble gas before Fe is Ar. And then I'm going to write just the things that come after Ar, which is 3p6, until I get to iron at 3d6. So that's the 4s and the 3d. So again, the only difference on that, had we been asked to do just plain neutral nickel, we would have ended at 3d8, but instead this nickel has lost 2 electrons, so instead of ending at d8, we've ended at d6. So the only extra step that you have to do is to consider this as if you're writing it for a different element that's shown. My valence electrons, just as before, the highest shell, it's the 4th shell, 2 in it, 2 valence electrons. Another example of an ion, in this case I have a negative ion, so it's sulfur 2-. Here's sulfur on the periodic table, but I'm going to be doing this as if I've gained 2 electrons, so I'm really going to be pretending that this question has asked me to write the noble gas configuration of Ar. So looking at this, here would be sulfur at 3p4, sulfur 2-, so it's gained 2, so I'm really writing it as if I'm going to 3p6. And the nice thing about this, Ar is a noble gas, and the noble gas configuration of a noble gas is a noble gas. How convenient. That's all I have to write, because it's a noble gas already. My valence electrons, sometimes when students get this, they'll tell me 0 for valence electrons, because they didn't have to write anything after that. Just remember that this Ar is abbreviating this full electron configuration, because Ar goes through 3p6 on the periodic table. So you can look at that and see that the third shell is the valence shell. It has an s and a p part. Those are my valence electrons. So I have 8 valence electrons. Last example here, another ion, Mg2+. Here's Mg on the periodic table, would normally be 3s2, but this Mg has lost 2, so I go back 2 squares to Ne. Alright, another noble gas. So, noble gas configuration of that noble gas is the noble gas. And for the valence electrons, remember, just because you don't have anything written after that, that Ne is standing in for 1s2, 2s2, if I can write correctly, 2p6. So my valence electrons are those in the second shell, 2s2 and 2p6, 8 valence electrons again. Okay guys, so just to recap, whenever you do these problems, you should have out these 2 things. When writing the full electron configuration, you are writing the last part of every letter until you get to the place that you stop. If you're writing the noble gas configuration, remember to go to the noble gas that comes at the end of the row before your element, and then write just the things that come after the noble gas until you get to the element in question. And if you have a thing that is charged, remember it is like asking you to do a different square on the periodic table. Either go forward if it's a negative charge, or go back if it's a positive charge, and just pretend like you were asked to write the configuration for that element. Talk to you guys later.